يس شغال زي الفل.
Hello everyone, good evening. Can you hear me? If you can hear me, please let me know. Okay, great. Great, thanks. Thank you for joining us today in our session, the fourth session of our series, Embracing AI in the Geospatial field. And today is the fourth session. We will have a session about turning geospatial data into actionable intelligence using GeoAI, presented by Dr. Adel Bolbol Fernández. And you are pleased to have you all today as African woman in GIS community. Dr. Noha, please, next slide. As we started our series, we are some member from African woman in GIS community. Dr. Noha Abdelwarth, Events and Training Coordinator. Letwin Bondo, Southern African Zonal Coordinator. Carol Nigiri, a member of Events and Training Team. Haneen Mohamed, Assistant of Northern African Zonal Coordinator. And for me, Safinaz Mubarak, Northern African Zonal Coordinator. Dr. Noha, she will present a few information about our community.
Okay, hello everyone. Can you hear me?
Yes, your voice is clear.
Okay. Thanks for joining our new session. Thanks, Dr. Adel. It's a pleasure that you accept our invitation. At first, please let us all pray for people of Sudan. May Allah save and protect them. ربنا يحفظهم إن شاء الله. For our audience, if this is your first time participating in our sessions, we are African women in GIS community. Please. Our community was made up of African women around the world who work, study, or are enthusiastic about the geospatial industry and its related field. The community aims to allow its members to be themselves, create networks, gain mentors, get career advice, partake in geo projects to improve their portfolios, access job opportunities, as well as geo course information, and showcase their work to the world. We can do all this things through our activities. So our activities are available for all people. However, the membership is only allowed for women. Also, the mentorship program are also allowed for women only. If you would like to know more information about the community, please stay to the end of this session. I can take you in a tour about the community. So this session will be uploaded to our YouTube channel, and all previous sessions are available now in our YouTube channel. Now we will send a link on the chat box, included all social platforms links and the membership link. Also, you can check our Arabic and English story map. If you want to get a participation certificate of this session, so we will send the form of the participation certificate in the chat box now. Okay, ممكن نتكلم عربي علشان خاطر الحضور محادثين اللغة العربية. أهلا بيكم. إحنا مجتمع المرأة الأفريقية في نظم المعلومات الجغرافية. إحنا عبارة عن مجتمع من الهدف منه إن هو بيدعم البنات أو النساء اللي بيدرسوا أو بيعملوا في مجال نظم المعلومات الجغرافية والمجالات المتعلقة بيها. من خلال الاكتيفيتيز اللي احنا بنعملها، احنا بندعم العضوات الكوميونتي وبنقدم لهم الارشاد والتدريب اللازم. كمان احنا بنعمل ايفنتس كتير زي ما انتوا حضرتوا معانا قبل كده. بنعمل ايفنتس وبنعمل كورسات، والاكتيفيتيز بتاعتنا عموما هي افيلابل لكل الناس ما عدا طبعا العضويه، طبعا هي للبنات فقط، وبرنامج المنتور شيب هو للبنات فقط. دلوقتي انا هبعت شويه لينكات في الشات بوكس، لينك للحابين ينضموا من البنات للكوميونتي، ولينكات اخرى خاصه بالبلاتفورمز، سوشيال ميديا بلاتفورمز. كمان لو حابين تحصلوا على شهاده حضور للسيشن دي، هبعت اللينك بتاعها حالا ان شاء الله. وكمان هبعت لينكات الستوري ماب باللغه العربيه وبالانجليزيه. وان شاء الله في نهايه السيشن لو حابين ممكن نتكلم اكتر عن الكوميونتي وعن اهداف الكوميونتي وايه هي الاكتيفيتيز بتاعتنا بالتفصيل. بس عشان ما نضيعش وقتكم ووقت دكتور عادل، فاحنا دلوقتي صافي.
Yes, Dr. Noha, thank you for this
Yes.
wonderful speech.
Thank you.
Okay, now let's move to our speaker, Dr. Adel Bolbol Fernández. He is the regional business lead for the public sector covering AEC, infrastructure and transportation at ESRI. He has 20 years of experience working with special data management, analytics, and GIS consulting in several domains, including utilities, transportation, land information, defense, maritime, aviation, weather, and archaeology. He had PhD in geoinformatics from University College London, UCL, on using machine learning for understanding movement and behavior. Also, his master degree in GIS from City University London and APM PMI certified. He is also a member of the British Computing Society, BCS, Open Geospatial Consortium, OGC, and Association for Project Management, APM. We are glad to have you today, Dr. Adel. احنا طبعا سعداء بكم جميعا، وشكرا لحضوركم النهارده، وتشرفنا بقبول الدعوه من دكتور عادل ان هو يبقى معانا سبيكر في السيشن بتاعنا النهارده. هو طبعا هيتكلم عن يعني جزء حلو قوي وحاجه لسه جديده، ازاي نستخدم ال AI في مجالنا كمتخصصين نظم معلومات جغرافيه. دكتور عادل.
Thank you very much.
You are welcome. It's our pleasure to have you today.
Thank you very much.
The floor is yours. You can share your screen and start.
Thank you very much for the kind introduction. I'll just share my screen at the moment. So is this clear?
Yes. Yes.
Perfect. Thanks very much for making the time to sit through this session. Today I'm going to talk a little bit, like we just discussed, we're going to talk a little bit about basically location intelligence and turning geospatial data into actionable intelligence using GeoAI or geospatial artificial intelligence. I'm going to talk a little bit about, I'm going to start a little bit in summary on talking about around the topic of information intelligence, about AI, machine learning, and the different ways we understand it, also about data and the concept of data. But then I'm going to go a little bit into how in GIS or in geospatial and this geospatial technologies side of things do we perceive the use of GIS, and how do we navigate around it. I'd like to start with a small statement which says, and I'll talk a little bit in English and in Arabic just to make things a bit easier. But basically a statement that is very, very truthful for what we do today in our work in technology, which is, again, as Albert Hubbard said, one machine can do the work of 50 ordinary men, but no machine can do the work for one extraordinary man, which basically summarizes that we can have automated processes. We can have a lot of things that are put in a system where that kind of does a lot of work of normal men, normal people. Again, men here means in generic sense, men, women. But no machine can do what an extraordinary person would do. So what we want to say here is that there is a level of intelligence that we today can achieve using machines, but we can't replace still the human sense of things, the human wisdom in some sense. If you're familiar with the notion that comes from philosophy, this is the triangle of the data, information, knowledge, and wisdom, or DIKW. Triangle, and this very much in psychology and philosophy kind of understands that how the human brain works. أو مخ الإنسان. This works very much with a center of data. We perceive data, we see data, we transfer that data into information. That information moves into knowledge. Year after year, day after day, we see a car in the street, we realize that this is a car. We know now that cars tend to go fast. If there are cars, we cannot cross the road fast. We can see cars far away. We always worry. So this kind of develops the knowledge, the understanding of the characteristics of a car and what it does. But then there's the wisdom, which is the top of the triangle. Years and years and years of work after sitting through lots of time, lots of experiences, lots of data sets, information and knowledge, we start acquiring wisdom. Lots of people, أو زي ما احنا بنقول في ناس كتير قوي عند في سن ال 50 60 بيبتدي عندهم حكمة أو the wisdom. With wisdom is exactly that. Wisdom is us understanding the dimensions of any problem. نبتدي نفهم الأبعاد بتاعت أي مشكلة. Wisdom is what every human wants to achieve. Now, the thing is, when we translate that to any company, any technology company, or any organization that works with technology, this translates to data that kind of is acquired over a very long time. بنقعد نجمع data كتير قوي بنحفظها في database, or we store it in a database that kind of translates into a big data lake. And then on top of that, we use lots of small tools. بنستعمل tools كتيرة جدا. التولز دي بتبقى بتساعدنا to understand and analyze the data better. So we start using these tools in order to apply certain algorithms, certain analytical tools, which we can call advanced analytics. Advanced analytics helps us to summarize data, make sense out of this big data, but then we go into AI, or artificial intelligence, and that's when we can translate that, make sense of the intelligence that we got from the data into getting the machine to think for me, to make decisions on my behalf, and involve me as well in a semi-supervised way to understand that data better. But then the wisdom piece is very hardly achievable by computers nowadays. We still haven't achieved wisdom by computers. لسه ما وصلناش للليفل بتاع الحكمة في استخدام الحواسب الآلية النهارده. Okay, so today we have a lot of data sets. Data sets come from lots of IoT machines. We have a lot of data collected. We all know this, where we all know that we have a lot of phones. These phones produce a lot of data. This data goes into storage. We have a lot of data being stored across time. Problem is, we acquire this data, but lots of times we don't know what to do with it. Lots of times we think like we have a lot of data, let's use machine learning, let's use AI to do things with it. Problem is as well, the data sometimes gets stored for too long in lots of archives. زي ما عندنا موظف في الارشيف عنده داتا كتير قوي، عنده ملفات كتيره جدا بس مش عارف يعمل ايه اي حاجه. We can't use this data, we can't translate it into anything. Now the idea here is to store the data in a way that is indexed in the correct way for us to retrieve the data in a very easy way, the way that helps us to move on with our analytics, move on with artificial intelligence, and automate our processes. جزء من البروسيس كله هو storage، طريقه حفظ الداتا نفسها، حفظ البيانات، ومنها كمان الاناليسيس والاندكسنج بتاع البيانات. يعني احنا نعرف نسجل الداتا بطريقه تسهل علينا ان احنا نعرف ندور على الداتا اللي ليها علاقه بالمشكله اللي احنا بنحاول نحلها. So moving on, so there's sort of a cycle here that we start thinking of, which is again the resolving the data. So we use big data in order to empower AI on one side. So AI is on the left, data is on the right. We try to use big data in order to empower AI to make more sense of it. The more data we get, the more intelligence we can extract out of it. But also, the more intelligence we get, the better we can start saving data and prioritizing data and filtering data and summarizing data. If I get a lot of data about cars, and عندي النهارده collected data كتيرة قوي عن سيارات مختلفة، brands مختلفة للسيارات. At some point, I want to understand what's the lesson learned. Why do I need to store all data about cars? Do I need them in order to understand when accidents are going to happen in my roads? Do you need to store the data? Then store data about cars to understand the speed, the different speeds that they drive on. Do I need to store them to understand where the locations of where cars park? There are lots of problems now that AI tend to help us as well on the other end to store big data in a certain way that I don't need to resolve to store in all this amount of data, this unlimited storage for no reason. So governments have used AI very much, and this is a study done by Deloitte, consultant agency, where they have tried to quantify the amount of savings that AI saves for governments. So what they've done is they've gone for around 700 different companies and government agencies. So they went through 700 government agencies around the world, mostly between North America and Europe. And they started quantifying the amount of processes that they had and the amount of AI that is involved in the processes that they do, and the amount of hours and dollar signs or amount of money and costs that they save using AI. And as you can imagine, like on the lowest amount of investment, tasks were sped up. So it was sped up by 20%. So some agencies use the least amount of things. So I mean, part of AI could be automated stuff, things like using emails, for example. That's a form of machine learning. That's a way of prioritizing data, filtering data, sending data, and so forth. Automating processes. There's another more intelligent part to do with understanding your patterns and trends, the way data evolves and the amount of information I extract from it. So lots of agencies that have spent a lot of money on investing in AI inside government authorities have tended to kind of save or achieve savings by 200% of what they currently spend. So if they spend, let's say, $1 million a year, they would have saved at least $500,000 a year on using AI. So there is a lot of value in using AI. It's money and time. Now, the idea here is that there are problems like, there are usually the problems that were in governments where we see We don't have enough people to kind of do certain processes. We don't have enough. There is a lot of paperwork that we have to go through in order to achieve certain things. Today, a lot of municipalities, بلديات كتير جدا, they need to do licenses and do paperwork that today they've digitalized, but not just digitalized, but also find a way in order to achieve certain certain algorithms to prioritize the amount of data, the number of documents, the things that they need in order to address certain aspects. Now, the thing is, these problems are very different. Some of them are just simple automation. Some of them are more intelligent. They go into the advanced analytics side of things. Some of them go into AI. Now, how does this kind of achieve or kind of go into different parts of governments? There is a lot of studies, and that's a study done by McKinsey, if you've heard of McKinsey, where they've kind of broke down the value of AI and which areas they kind of helps in business. And some of it, a lot of it, there's a lot of money that goes into retail and banking that AI kind of helped with. That's mostly all the money that's the sectors that have been involved in. Consumer packaged goods, travel, logistics, transportation, insurance, public sector, and so forth. But when it comes by business, a lot of it has been done on, a lot of intelligence and AI has been used in marketing and sales mainly, and supply chain and manufacturing. When it comes to things like business problems, certain sub areas, those have been things like customer service side of things, predictive analytics, churn reduction. So it's very, very retail and commercial focused. Now, this is not just the case. So when you say commercial or things of that sort, that also applies to government. The thing is here, GIS is pretty much the same. We all know as GIS users, GIS is involved in every one of those sectors. GIS is pretty much like any other technology. It's one of those, any other big technology that kind of gets applied to everything else. So for us here, when we look at spatial technologies, we have the analysis side of things where we say there's certain analytical methods and things. If you've used a lot of the ArcGIS or Esri's technology before in the past, yeah, you would see there's a lot of techniques that use certain analytics like network analysis, like spatial analysis, in order to identify certain aspects. What data science does on top of that is that it looks at all those analytics, but also identifies patterns. It starts understanding trends, understanding anomalies, which kind of means things that are out of the normal pattern. And then artificial intelligence, or AI in general, kind of adopts a lot of machine learning techniques in order to solve a bit more complex problems that are not just based on patterns, but also based on the machine learning those patterns and start trying to identify those patterns in different aspects. Now, when it comes to what we're trying to do, or software companies in general try to do, and that's not just Esri, that's lots of software companies nowadays, they try to focus on three different parts. First of all, the data itself, the storage of the data, how we store it, the formats, the way we store the data. But the second thing is the engines as well. What kind of engines and functions and processes that go into it? What kind of tools can we use in order to access those processes, make them faster, make them easier? And the third part, which is the very important part, which is the experiences. The thing with data science is, why has it become so popular lately? It's not just the processing power and the storage power, but it's also the way the user interfaces that, and the way the users and developers use it. Lots of us are not computer scientists. We're GIS people. We all kind of understand spatial location. But the reason how we get into an analytical platform, or we do an AI, or we use AI, is because there are tools that make it easy for me to do it. I don't need to be a developer lots of times, and don't need to understand code very, very much, but I can still do a certain amount of development using, let's say, ArcGIS, for example, desktop. So I could go in ArcGIS Pro, I can do certain activities, I can run certain processes and workflows using a user interface that is more user-friendly than having a code and programming in order to do things. And this is the idea, is here lots of software companies, again, not just Esri, they tend to kind of try to bring all these together. They bring everything into one platform to make the experience, the developer experience, way better. Now, on the data side of things, there's a lot of types of data that go into GIS, and you're all familiar with this. I don't need to tell you a lot about that. But apart from tabular data and vector and imagery data, there's also a lot of data, newer data like 3D data, BIM or building information models that kind of come from the CAD and the construction side of things and the architecture side of things, real-time data, multi-dimensional data, data that has X and Y and time, so things that change over time. Also graph data, so graph data is data that is correlated. So person A and person B move in different places. How this person A is related to person B and where they've met, where are the places where they kind of have been together, or which cafes have they sat together in, which certain common geographies they've been together with, and how are they related, the different degrees of relationships that they have with each other. That's what makes graph data. And there's a lot of types of data that is today nowadays, not like in the past when we had vector and raster and that's it. Today we have a big range of data sets and geoinformation models that we use. Now with the data, the idea is that in order to have anything that is ready for analysis in the right way, we need to have a whole process that collects the data, models the data in the right way, stores it in the right way, so can extract the right information from it, maintain it, prepare it for analysis, and then share it across after we analyze the data, visualize it in the right way. And the more important thing is AI or machine learning is very, let's say, it's cool, it's good, it's nice to kind of work with it, but at the end of the day, it's useless if I cannot present it to decision makers. I need to have متخذ القرار or decision makers, at the end of the day, need to have this information in order to make use out of it. If I can't present that in an easy way to visualize and to interpret, then it's all useless. Now, the storage side of things, there's a lot of types of storage, and then I'll just walk you through this quickly just to understand the different types of storage for those of you that want to pick up a lot of this and work with it. There's lots of file-based data sets, file-based data, that could be stored into SQL data sets, and this is a snapshot of them. The most common ones are obviously Azure SQL database, Postgres SQL, SAP HANA, but then Oracle Postgres SQL and SQLite and so forth. They're all different databases where you can store the data and start working based on those databases. But then data lakes, there are different, again, platforms where you can store your data. So you have bigger data lakes where they're structured in the right way. You can very much store it on the cloud and retrieve that data from the cloud. And that's that. You have examples here. A lot of it. Some of you might have used S3 buckets from Amazon, for example. You could have used Azure data lakes and so forth, or Alibaba Cloud Storage. There's also cloud data warehouses, and those are for those of you who are familiar with Snowflake, Google BigQuery, Amazon Redshift. There's a lot of those data sets those ways to store data, or those kind of enterprise data, data sources where you can store and collect data. That depends on the amount of data that you've got. So it depends if it's a manageable amount, you can store it again on an SQL database. If it's a huge amount and it goes into a big data realm, but you want to store it in different bundles or different packages, you can put it on a data lake. And obviously you have a cloud data warehouse where you can organize that data, retrieve it, do queries in a very efficient way. But then when you move to after the data, if you remember on that slide, there was also engines. So engines, there's different types of engines that exist to deal with different types of data and do different things with the data. There's some engines that kind of do all the AI and the machine learning side of things. Each one of those data sets will have a specific engine that you will let me just go back. Sorry. So if each one of those, by the way, is going to have a toolkit, a specific toolkit that you're going to be able to work with, a specific toolkit that you can use and that's inherent inside ArcGIS, that has ArcGIS Pro, that has different set of tools inside that you can do things with it. So some of it deals, as I said, like with machine learning and deep learning. Some of it deals with the raster analytics, with all satellite imagery or remote sensing data. Some of it deals with big vector data analytics. Some of it deals with real-time analytics. So all understanding real-time sensors, smart meters, for example, things of that sort. And some of them deals with graph analysis, and that's very new for us in the Esri world. But then network and routing analysis as well. Now, with experiences, you have different experiences. So lots of you today have heard about notebooks and Python notebooks specifically are very common to kind of build your code. If some of you are using some code like ArcPy library package, for example, inside Python, or other packages that go with machine learning, you can use notebooks nowadays to write your code, but also as you write your code, you can visualize what the code does to your spatial data as you go. So it shows you the map. It shows, as long as you import ArcPy, kind of shows you things inside of it. But then there's obviously the desktop side of things where you can build your workflow and in ArcGIS Pro, for example, and do things. There's mobile applications nowadays as well that kind of enables you to visualize the data. Maybe not so much on doing the development side of things, but mobile applications help you visualize the data, deal with it, add data, feedback into your enterprise. But then Insights as well is one of our products that kind of it's very much focused on the high level analytics, not very much the detailed analytics, the GIS hardcore stuff that we do, but it's more of having a business intelligence type of tool. Now, also within the experiences, there's a open and integrated scientific community. So some of you that might think and see, for example, part of the just go with that. So some of you that work with some of those packages, there's skitlearn, for example, if you can see that on the left here, is one of the Python packages, for example, where you have a lot of data sets you can use. PyTorch is another one. It's another toolkit that kind of helps you to build a lot of Python packages and work with it, Jupyter Lab and so forth. But then you also, on our side, we kind of developed a lot of spatial data science type of Python notebooks that help you deal with these things. Some of you might know SAS and RCRAN. Both of them are they're both open. You can download them online and work with them. They are very easy to learn. You can start learning how to kind of develop an array, matrix, data frames and things of that sort. It helps you very much do analytics from X plus Y equals 2, for example, to very hardcore stuff that goes into data science and the realm of data science. Now, this is all what we do nowadays, or what we do as in ArcGIS. What we did lately is we integrated all that to kind of be linked into the same infrastructure, so you can use any one of those packages inside your R, for example, codes, or inside ArcGIS if you're ArcGIS Pro, and you can inherit any one of those and feed it into your data set. Now, there's a lot of way that kind of advance with spatial science. What we do is we kind of focus on different areas, or broke the whole process into several aspects. And if you remember in the beginning, I spoke about the data engineering side of things. So taking the data, not just storing the data, but storing it in the right way, bringing out the right labels. And I will go through an example in a minute. But also going into the visualization and exploration. So you look at the data, you put it in a map, just look at the map, how it looks like, see the patterns, see how the data looks like, and then do simple spatial analysis. Now, when spatial analysis is enough, that's good. If it's not enough, sometimes you think like, well, I need to get the machine to kind of think on my behalf. And that's when you start looking at different packages, like different Python packages, different tools that you need to use in order to help you with the codes. Now that there's a lot of big data analytics side of things as well that you need to be aware of. So it's not just machine learning on its own, but machine learning is only useful if you are using a lot of big data. If you have a big amount of data, if you have little sample of data, the machine doesn't have a lot of information to learn from. As simple as that. You, by the age of when you turn 30 years old or 40 years old, you are old enough and to make decisions, to think and have certain intelligence, just because you've seen a lot during the last 40 years, right? And this is exactly the same with computers. You need to have a big amount of data in order to be able to have a very efficient machine learning technique that works with you, a machine learning algorithm that works with you. And big data is not as simple as just using its own. It requires big data repositories, certain type of queries, big data queries that you can run. It's not as simple as SQL. It's a bit more detailed because there's a huge amount of data that you need to deal with, and it takes a lot of time. But then the modeling and scripting and writing the code is obviously part of it. But the sharing, as I mentioned, as long as you can share it in a way that makes sense and people can understand it, then it is useful data. Now, the idea is with geography, you bring all this kind of stuff into one approach. And this is what we've been calling lately in the past couple of years, the geographic approach. The geographic approach is bringing everything together, bringing all these processes in one thing in order to help you to achieve that. So let me just move on a little bit into the side of algorithms. So there's lots of advances in spatial statistics that we've done lately, and we've seen. And lots of it is to do with, again, raster functions and tools. So trends and predictive analysis, data aggregation, change detection, pattern identification, understanding, having data, but then realizing, well, I have this data, but I also have some census data, let's say. And how do I bring this census data, which is the census that's collected every 10 years for a country? How do I add the census data to my existing data in order to enrich it and make it more valuable for me? So there's lots of stuff on the raster analytics side of things that I would like to look into. I'll just shift into a page here that might kind of summarize this a little bit. And here's basically an example, a nice example of it to kind of summarizes it on ArcGIS Online. So basically, there's a store map here that kind of summarizes a little bit all the feature extraction methods, and basically those are kind of different examples of feature extraction. Now, when I say feature extraction, I mean looking at the boundaries of a certain feature and extracting those boundaries. This example is here. You can see an example of building a footprint. I'll share this with you, by the way. This is the story map. It's open publicly. You can look at it and look through it for different examples. But here you can basically, we use here machine learning, or more like here, we use deep learning in order to start extracting parts of a parcel. And you can see here, like one of our tools that we developed is a swipe, where you can go and see how did the algorithm extract those types of building footprints. Now, how did I achieve things like that? This is used using what we call deep neural networks, and it uses artificial neural networks. If you've heard of the term, it's one of the techniques that kind of helps you to stimulate how our brain works to understand things. If you look at that image on the left, if you look at this image here, you start realizing, well, those are buildings. They look like buildings. The reason why you know that is because your brain starts looking at those and realizes that I've seen buildings so many times from a satellite image that I can interpret it in this way. Now the machine needs to create polygons around each one of those buildings automatically. How do I get it to do that? Is again using deep learning. Deep learning. So I don't want to jump ahead, but machine learning kind of helps simulate a lot of or teaches the machine how to do things using a certain process, and gives it a lot of parameters in order to use those parameters to extract certain things out of, let's say, images, for example, or data sets that you have. But then deep learning does a little bit more than that. Deep learning simulates how our brain works, how neurons in our brain go from one layer in our brain to the next, and helps computers to kind of understand or use the same logic that are used in our brains in order to extract those types of buildings. There's a lot of details about neural networks and again deep learning that we can start talking about. But here, this is another example of, again, a few examples here. This is an example of extracting the shadows of images of fields in the Arctic and the polar side of things, in order to extract number of seals from satellite images. And here you can extract the number of seals, have those counts, and for conservation processes, you can better understand the life habitat that you've got. Another important one is like things like road extraction. We've seen that in lots of places in the US, lots of places in Africa as well, where road extraction, you don't have a road network, and that's a problem. You don't have roads at all. You don't have any details on the roads, but then you use satellite imagery and deep learning in order to extract those roads. Another example is extracting things like swimming pools, for example, inside houses, or other things within with that are similar, that other characteristics of houses, or counting number of trees or palm trees. I must say, palm trees is an easier thing than normal trees. Normal trees tend to blend with each other. Palm trees have a certain pattern that's easier for computers to understand than normal trees. So palm trees are usually they tend to kind of have very high success rate than normal trees. But then wind turbines is another one where we don't have data sometimes of things like wind turbines, for example, and you can use again deep learning to extract that. Another thing we've seen with a lot of municipalities around the world, where they want to do road maintenance and you don't have any data on that. Again, having a drone kind of fly on top of on roads, or even a mobile camera, where someone holding a mobile camera on a car and driving around the roads, you can use again deep learning in order to extract those areas. And when you look on your roads, you can see which areas of the roads require what type of maintenance to kind of deal with the road cracks or pitfalls or holes in the roads. But then other things are, again, extracting well paths and tree detection, as I mentioned before, depending on the pattern of the trees. But then this is one thing that uses deep learning. Another thing that you might be familiar with is land cover classification. You might have seen this before. Now with land cover classification, there's a lot of satellite imagery. There's different types of satellite imagery, as you might know, where you can use, again, remote sensing in order to extract certain aspects within the soil. So things are like using different color bands, and lots of you are already familiar with that. Maybe if you're heavy users of GIS, where you use again NDVI, or the reflectancy of satellite imagery and the combination of different bands with each other in order to find out the different types of soil types that you have. And here, so if you can see that, you can tell here that that using remote sensing and using the different types of color bands that you have, you can start extracting things like roads. Concrete structures, like things like buildings, things like permanent, like vegetation type, crop types, and things of that sort. But then you can also, from images from satellites such as Sentinel-1, you can start extracting things like, again, from using the red and green and blue color bands, you can start extracting things like the land cover within land. So this is just not loading for a sec. We can move on to the next one afterwards. So think again, if you remember in the bit in the top, when we were using deep learning, we're using feature extraction. Deep learning helped very much with creating vector roads out of my imagery. Whereas here with land classification, I can identify still raster, I create raster. Out of the raster, I can start creating using nearest neighbor process in order to understand or create vectorize my raster outputs that I have here. But in general, I can get way more things than using feature extraction. Feature extraction will help me with things that have edges, things that have a certain structure. Whereas here with remote sensing, if I want to use again, if I want to extract everything that's to do with the Earth surface, and here I'm not going to use edge detection or what we call feature extraction. Here I'm going to use remote sensing and machine learning techniques in order to use remote sensing and extract those aspects. This goes into other things like mangrove classification and so forth. Now, another thing is scene text parsing, and that's another thing that you might think like, yeah, I mean, it's fine. I can extract, yes, out of an image, I can extract certain text, as you can see here. It kind of, the image goes through certain things, identifies where text is, that tells you, oh, this is a road sign that says one way. This is a road sign that says wrong way. This could be, by the way, it's not just English. There are lots of library packages that use Arabic specifically as well, or other languages, other alphabets in order to understand those text parsing. So this is becoming more and more global now, inclusive of the rest of the world. And when you get those signage out, so what's the use of that? The use of that is that you drive, for example, down the roads, and you want to see, you want to capture all the assets that you have, and you don't have a database nowadays in lots of municipalities and places in Africa. You don't have a database that tells you where my signs are, which signs are broken, which signs need maintenance, which signs need to be colored or painted in the right way because the color faded or has been broken sideways. And in order to do that, you can start taking even a video across while driving your car. And because you're grabbing also the location, you can identify which signs are located in which area. And you can see here in top right, it tells you like you can create that kind of database in the end that tells you on these locations, there is a certain sign that says wrong, one way, two ways, and so forth. And that kind of helps you with road maintenance, with maintenance of roads, road aspects. But this helps you a lot with other aspects that I'm going to go into now with natural language processing. Now, if you remember, there's a lot of other articles. Those are some articles that I found that I thought might be relevant to you that kind of talk you into, again, fine-tuning a model. So today, what we've done as well in ArcGIS is, and this is a very, very good example of how you can run and throw yourself into it. Basically, we've created what we call a pre-trained AI model. So all these kind of slides all these kind of stories that we looked at now, all those examples we looked at, we've created an AI model that's part of it. Now, how do you create an AI algorithm or a machine learning based algorithm? Very simply is that you have to have data in the beginning, like I said on the slides. You take this data, you label it. So you say, for example, this is a road, this is a tree, this is a so-and-so. So you classify it, for example, and then you go into the algorithm and you tell the machines, those are examples of trees. These are examples of different trees. Those are examples of cars. These are examples of different types of cars. These are examples of even people, even certain aspects. But then with the algorithm, as simple as you say, well, now this is an object. Tell me what it is, and this is when machine learning helps you to identify certain things. Now, let's go back now. So we have to start with the data, right? The thing is, lots of times I don't have right data. I don't have data. I go, let's say I have a satellite image and I still want to look at my data and start saying, well, I need to give the machine, I need to give my computer a lot of data to learn in order to make those decisions for me. What we've created here is a pre-trained data set, and that's something that you can, this is something that you can find here. It's I'll share this link as well. It's basically a framework that kind of gives you a deep learning framework that kind of gives you all the algorithms, all the Python packages that you need in order to build those algorithms. But also, as part of ArcGIS Desktop or ArcGIS Pro, we've also put a pre-trained deep learning model. That means that we give you a lot of example of certain things, and those are example of those things. That all the stuff on those pages are example of those things, as a natural habitat, certain buildings, roads, and so forth. And so it gives you the data already, example of the data, and you can go to a place, for example, in Uganda, a place in South Africa, a place in Cairo, in order to start saying, well, I already have learning data. It's provided by ArcGIS, and what I want to do is I want to extract, let's say, roads, or I want to extract vegetation or things in this part of Cape Town, for example, this part of Cairo, this part of Marrakesh, for example. And this is exactly what we're trying to do, and trying to make it easier for developers to start developing, enhancing basically the user interface. Now here, just bring this down a little bit. So what you need to do, there's an article here that's very, very useful. It kind of talks you through all the different packages that you need to put in Python. If you need to be working with Python here. That's a prerequisite. You need to learn Python. It's one of the very, very useful data science toolboxes, languages that you can use. It has a lot of toolboxes inside of it, a lot of packages, Python packages that you can use in order to work with those algorithms and build the algorithm very well. But then we've also, as I mentioned, we have a deep learning framework in ArcGIS that you can install that kind of has all these packages, and based on that you can start building things in the way that I just showed you. Now, going back to my slides, we've spoken about imagery. We've talking about different types of things that you can do with raster analytics, and again, this slide kind of very much summarizes it. It kind of tells you very much where you can basically sorry, I'm just yeah. Okay, go back here. So this is very much kind of helps you understand what type of things that you can extract. So you can extract a lot of things out of your toolboxes. It's not a hard thing. But then the thing is, what we kind of did really in ArcGIS nowadays is have the whole life cycle. So from the imagery access, gives you the imagery, gives you access to in ArcGIS, Live in Atlas. We have lots of imagery that you can use and you can start working with. But we also put in, if you have your own imagery, you have a lot of kind of imagery preparation tools, things that help you label the data. So if you remember, I was saying, if you have data, you need to label the data, you need to put stuff on top of it. And here, data labeling is part of the process. And we've created different functions. One of them is called prepare my data using labels. One function, for example, that helps you kind of deal with data and label it easily. But then going into the training, because we've created tools that you don't need to even code in order to start using that data. And as well, the whole idea in the end is taking the right decision or taking the right action, having actionable intelligence in the end. So as long as you say, for example, crime usually occurs in these parts, let's say of Cairo, for example, and I want to predict in the summertime when there is a football match in the certain part, which parts of the city does crime is more likely to happen. This is when I can deploy the right policing efforts in order to kind of mitigate the situation. Or let's say if traffic is going to happen or is going to increase in certain parts of the city because the weather is above certain degrees, if certain conditions are met, and therefore these are the areas where I need to have better traffic management in certain areas in order to ensure that things don't go wrong. Now, maybe there's also a lot of work to do with things like inspections or understanding. So here, for example, this is an example of, let me just go back one. So the example of something in Abu Dhabi that we've done before, which is basically taking an animal farm, and based on this animal farms, you have a lot of inspectors that go around to kind of make sure that farmers are actually farming what they say they're farming, because they receive subsidies from the government. So they receive بياخدوا مساعدات من الحكومة عشان يعملوا أو يبتدوا يزرعوا محصولات معينة متفقة مع الاستراتيجية بتاعت الحكومة. The government tries to give farmers certain indicators, tells them, well, you need to farm and grow certain crops for our national interest, and therefore we're going to pay you subsidies, we're going to pay you money. And in order to make sure that farmers are not just basically lying, they say, okay, how to control this? Let's send inspectors. Problem is, they don't know which inspectors to send to which land farms and which areas are not reporting the right things that they're building. So what happens here is they've had the drone fly over certain areas continuously, every other day. And then with the drones, they kind of started using machine learning. Sorry. They started using machine learning in order to start looking at or classifying areas where they say, for example, start looking at areas where they have certain reflectancy. So they started using NDVIs in order to extract vegetation in certain areas, and then they started looking at each land plot and saying, well, if you have more than 10% of your less than 10% of your land or your farm that has vegetation, certain types of vegetation that you reported, then therefore we should send an inspector for you to inspect this certain property or this certain land parcel. And it kind of does all these rules or builds all these rules in order to for you to understand and make sense out of those classifications, and sends warnings and tells you in the end, those are the certain farms that we need, the ones in red here, that are using their farm or the land parcel for different purposes. They're using them for things that they're not supposed to be using it for. So this is one very useful example. In the end, what you want to do is obviously present this to the Abu Dhabi land Abu Dhabi Food Control Authority in such a way for them to start making sense out of it and try to take decisions based on it. Another example here I want to talk about is again, understanding you have trucks. So you have trucks going around different areas in the middle of the desert, and they're not certain roads, they're not real roads. So what we want to do here is start each truck of those has a GPS, and this is specifically for projects that we have working in oil and gas. So in oil companies where trucks go off-site, they go on dirt roads, and they are not tracking anything. So the problem is here, obviously you have people, you have drivers of trucks that go in certain parts of the roads in the middle of the desert or the middle of the forest, and they don't keep track of where they are. They know the roads because they go there every day, so they know which roads to take, right? The problem is here, you get some drivers sometimes that don't show up to work. You get the new driver that comes in, he doesn't know the roads because there's no roads. It's all dirt tracks. It's all like we say in Arabic, it's مدقات في الصحراء. How to detect those roads or this dirt tracks is basically you have a lot of GPS data, and every one of those trucks has a GPS device that kind of tracks automatically the roads. That's for in the oil and gas area. This is done specifically to keep everything safe. It's just for security processes. Now, what we've done here is we've said, okay, there's a lot of GPS data. We have location. There was around, in this case, the onshore team of that company provided us with 14 gigabytes of GPS data. It's all CSV files, so it's all Excel sheets. Now, what to do with that? There's a location. There's an X and Y, and there's a timestamp, right, of where this truck was. But there's also a timestamp that changes over time. So the idea here was using machine learning in order to connect those in a way that goes with the flow of traffic. So here, as you can see, like an algorithm starting over time, starting enhancing itself in order to create a road track time after time. So as the data, as the time slide goes, you start moving on in and more in order for that kind of algorithm to get better and better and start adjusting that line. Now here we've used support vector machines. Which is again, don't get confused with the name. Support vector machines is one of the algorithms that kind of one of the machine learning techniques that exists. It's when you look at Python codes, it's just a function. You just put different parameters to it, play around with those parameters to get the best results. Support vector machines is good for things like this, things that have sequence. When you say at 3 o'clock, there was the truck was this location. 3 o'clock and 1 second, it was a different location. 3 o'clock and 2 seconds, it was a different location. And so things that go in a sequence are usually things like support vector machines are one of the techniques that kind of looks as very focused on sequences of things. So so things like this algorithm, support vector machines will be the right algorithm to, machine learning technique to use in order to make the best out of the data and extract those roads. Now, in the end, once you've done that in ArcGIS, after time and after injecting more data, we ended up with a road network, a big road network that is well connected. It also had directionality, so it also had the right telling you which direction followed which other direction. So gave you a lot about that connectivity, right? So moving on a little bit, there is another work that we've done that kind of involves, working with, in this case, it's a lot, but working with very different types of data. So this is data coming from a telco operator. So telco operator like Vodafone, like it's a lot, you don't want to speak about a lot of names, but telco data in general, they're all the same, right? So what telco data has is they have cool data records. Cool data records is basically having location of where calls have been done, where people have been using their phone, and so it kind of collects a lot of location data. But out of that, in the use of the pandemic and the use of understanding where things are, you can very much use that data. You don't need to know anything about a person, but here you can look at an overall picture in order to start understanding a bit more about the movement of data, movement of people, the understanding of where people are and which locations, the top nationalities are a certain location. If you have the demographics of people, you can understand the genders, the gender split in certain areas, top communities that have certain types of genders in it. You can filter by that data. You can also start looking at different times of the day to start identify those patterns and trends within the data. And this is obviously in the background, you can see this is a 3D map of Dubai. So you can see 3D buildings, the towers everywhere, but you can also see in the backdrop that's the perfect use of GIS, perfect use of understanding the visual aspect, but also the big data analytics side of things to analyze all this huge amount of data in order to start understanding the patterns around those certain different parts of the city. So very useful types of analytics that kind of helps you again understands very much the pattern and the life within a city. Other aspects to do again with predictive policing, and this is a very nice example of again understanding. You collect a lot of data, historical crime data. You collect as well demographics data, the seen as well which type of people kind of and victims, people that have been in prison a few times, understanding what your task force are and starting understanding using predictive models to understand things. But also there's a piece of work here that is really good where that's in London, and in the city of London here you had a so you have census data. It's open data, so it's all open data. It happens a lot in Europe where you have open data, but basically what that kind of gives you demographics. So according to your census, it gives you exactly in every small part of London, of the city of Greater London, it gives you the exact different types of demographics in it. Now you also have the data of crime data that has happened in different parts of the city, right? And that data is open data, by the way. Like any of you can go online, start looking at that data and download it. That's open data for the world. But download that data, you start seeing that you can start seeing those data sets overlapping with different neighborhoods that have, let's say, X number of men, X number of women, X number of different genders, different age groups, different types of demographical data that exists in each one of those small areas. Now, there's also the data of points of interest. So there's points of interest like, again, you have a Zara, a Gap, certain shops, for example, within different areas, or you have more restaurants in certain areas. You have more, let's say, nightclubs in certain areas and so forth. And then you have also locations of police stations and so forth. So you have every district has different characteristics and has a certain number of crimes and types of crime as well. So using this model, what they've done, the Metropolitan Police of London, what they've done is that they collected all this data together and they started using ArcGIS, looking at this data sets and starting drawing correlations between all these aspects, because where police stations are, how many police stations you have in this area, and and what types of shops do you have in this area, the opening times of shops in these areas, the lighting in the roads in these areas, the demographics that you have in these areas. And then it starts finding correlations, telling you these areas are the areas where you get where you you're more likely now. These are the areas you teach the machine. You tell it the more you have of these sort of certain demographics and points of interest and number of police stations, the more or less you will have out of each type of crime. But also in the end, what happens is you can predict that. So you're saying that my demographics now change next year, and this is my current demographics now. How do you predict what type of crime are going to happen in which part of the city? And this is very in-depth information. Obviously, this all relies on data. If you don't have the right amount of data, if you don't have the right types of data that is cleaned, indexed, stored in the right way, then you won't be able to achieve this right result. So this all depends again on data itself. Now, there's another part to do with natural language processing. If you haven't heard the term before, some of you might have, some of you might have not. But natural language processing is, again, trying to interpret and understand a little bit structured and unstructured text. So let's say I have a lot of tweets in certain locations. This is an example of social media in the US, and going on that's work between IBM and Esri that's been done a few years ago, where basically you look at different mentions on Twitter, and you start looking at language, so uses natural language processing or NLP packages in order to understand positive sentiments and negative sentiments of mentions within different cities about certain brands. So you look at certain brands here, you look at, I don't know, Forever 21, look at any type of brand, Gap or whatever, and you start seeing the number of mentions within a certain time frame and the sentiment and the brand performance trends and so forth. Now, this is, it's very geographical. It kind of has a lot of understanding. And maybe my last bit here is to focus on, or just to highlight on how this kind of links to everything. So here, this is an example here, a very nice page on using insights and kind of using Azure AI. There are lots of packages. Azure AI is part of it on text analytics. And basically with text analytics here, you can take unstructured text. I'll zoom in a little bit. But here you can take comments. And this is, again, you just use Python libraries. There's Twitter has an open sample data where you can download Twitter data from. There's a package on Python as well that kind of helps you to collect. It's called TweePy. It's a certain package that helps you kind of download all this data into a spreadsheet, into a database, into whatever. It has a location. You can filter by location, so you can only get data sets that has location in it. And you start looking at that, taking that data in. And what you can do is here in this example specifically, it's focused on the area of Washington, DC. So you can create a bounding box for it and only filter by that bounding box if you want to. You have in TweePy, you can do that. You can put a spatial filter for it, geofence for it, collect that data set, and then you can go into it and you can start collecting all these statements. So here I have a listing. It's just a filter that kind of goes through all these different examples, right? The idea here is that you use different algorithms. So you use first you use type of packages that do natural language processing. So it looks through a sentence, understands where's the verb, where's the subject and the object of the sentence, understands certain things. So it takes out the adverb, the adjectives, and things that are used. What that does is that afterwards you can use sentiment analysis, and there are packages afterwards that kind of does sentiment analysis. But out of those sentiment analysis, kind of those libraries kind of, it helps you basically look into extract sentiments and saying this is a positive, negative, happy, sad, angry, wishful type of tweet, and it kind of goes into classifying that by location. You can also extract names, so what they call name places. So if they're talking, if someone lives, let's say someone lives in Cape Town, but is talking about something in Johannesburg, then you can start kind of understanding like the sentiment of Cape Town residents about Johannesburg, or let's say people that live in Libya about things that happen in Morocco, for example. And you can start creating sentiment about certain world events to understand exactly the sentiment of certain countries about certain, that could be world events. So things like understanding global, again, gathering global intelligence. That could be other aspects such as, just like the other example we had on the other page, which is basically seeing different types of brands and seeing whether people are happy about, for example, Gap or Nike stores or Adidas. It could be about other things such as again just understanding what you're using. But then what that does is in order to kind of deal with this data, you need to create that's a tip for programmers and people that are working with things. There's what we call data frames, and data frames, they kind of help you store that in a form of a database like aspect that kind of has different layers and different dimensions of the data. And R, I've mentioned R before. R is a very cool language to kind of use and create those data frames in a very structured way, but then you migrate or take all that into Python. Now, Python kind of does all the machine learning stuff, so not just the statistical stuff, but so R does more of the statistical aspect and sort of data science stuff, but Python is more focused on the actual bringing packages together. Everyone nowadays uses Python for data science in order to kind of take this data, these listings, these sentences, and start using natural language processing and NLP algorithms in order to extract those text analytics type of aspects. Now, there's a lot of analysis. There's some those articles are going to share some of those with you, but there's definitely my recommendation, if you're going to go out with any recommendation that I had, is basically start using some of those tools that I mentioned in the beginning of the presentation, and I'm going to go back on them in order to bring out and tease out things of that example. And there's some example, for example, from foam data here, stuff that done in the past that kind of takes even movement of people on GPS tracks and automatically creates or starts understanding whether people were walking, driving on the bus, and road networks and so on. And these are sort of examples of, basically, you have a road network, you have a metro network, you have a cycling lanes, bus lanes, trains, and so forth, and you have GPS data. So on the left-hand side, you have raw data. It's all GPS data. On the right-hand side, you can, using machine learning and using geography, using all the networks that you have, using the speeds, limits, and very, very logical things, you can start creating a logical algorithm in order to understand how were people traveling around the city. Examples like, for example, here, where there's some rain that hits, for example, parts of Ghana, for example, in certain seasons. You want to understand what level of rain would affect what parts of my road network. And this is, again, another example from London and transport and London data. But it kind of helps you very much understand, again, the sensitivity. It could be wind, it could be temperature, it could be snow, sandstorms, visibility, any of that. And as long as you have the data that is stored from a road network, you can very much interpret that into data sets that you can work with and inject into things like Python and R in order to extract data sets and work with them. And as I said, starting point, a very, very good starting point is starting with that network. If I can bring the slide back. So things like, again, R and SAS to kind of start kind of working yourself through it. If you're already kind of familiar with programming and development in things like Python, and download Python, by the way, is an open source sort of IDE or kind of user interface that you can use. But you can inherit a lot of those toolkits that you have, like in the left here in order to start testing and playing with different machine learning algorithms in order to solve certain problems that you see. Again, you need to find, it's not just doing things because it's nice to play around with it. It's also understanding what is the problem I'm trying to solve by looking back whether I have the data for it or not. And if I have the data for it and it needs to be prepared in the right way, again, with ArcGIS, for example, or ArcGIS Pro or ArcMap, we have a lot of tools nowadays that can help you clean the data, organize it in the right way, to have it prepared for data science tools like Python, R to deal with it and make the most out of it. So that's my recommendation. There's a lot of data, lots of those packages online. They're all open, available. ArcGIS Pro, you can, if you don't have it, there's trial versions for it to kind of work with it and play with it. Python notebooks is free, even the ArcGIS one, so you can start playing with that already. So I recommend that go around and have a play around and start learning a lot of that tools. I think that will be me to kind of close the session, and thank you for listening to me. I know it's late, and Ramadan Kareem for those of you in the Muslim side of the world. But thank you again for listening to me and bearing with me.
Thank you, Dr. Adel. We got full of information today. Thank you for your presentation. And please, can you share with us the URL and your presentation with us?
I will send some of those links now. I'll share them on the chat, and as well I'll share them so they can share it with you, so you can share it with the whole group. But thank you as well. And I mean, African Women for GIS is an amazing group to be really presenting to.
It's our pleasure to have you, Dr. Adel. And we have many questions. Okay. They dropped it to the chat box. Okay, I will say it one by one. Mm-hmm. Okay, first one from Dr. Kareem. He wants to know what is the softwares that you use in AI, that we can use in AI.
So again, so let me make this simple. So using AI or machine learning, we use they're two different things, but they're similar enough. So let's just call them machine learning, right? And with machine learning, there are lots of, so there is the techniques, so certain things. Let's say I want to make it simple. So let's say, for example, there's think of multiplication. When you have the multiply sign, the multiply sign has certain, if you put 2 times 3, that's 6, right? So multiply sign is just a way to kind of do things. So the multiply sign itself could be, you could call it, let's say, it's a certain technique, right? The plus sign is another technique. The subtraction sign is another technique. Now, when you create the formula, so 3 times 4 plus 5 plus x and so on, that's an algorithm. You create an algorithm. So in the same way with machine learning in Python, if you download Python from there's Python 2.7 and there's Python 3, you can download that. It's available online. That's there's an IDE or a user interface for it, the developer interface that you can have online, interactive developer interface that you have online. If you download that, you start importing. There's a statement where you type in import certain packages. If you just Google it online, I'll say the simplest thing. Google, for example, let's say you're looking for natural language processing, NLP. So you can say Python package for NLP. If you Google that, it will show you what it is. You just look for it, import it, and in Python, the Python IDE, you just inherit it. Now, if you're using ArcGIS Pro, it makes it easy for you. It has already Python inside of it. So it already has all this interface for it. If you open the developer screen in the bottom of ArcGIS Pro or ArcMap, you already can start using Python into it. So it already has it. You don't need to download it. It's already inside ArcMap or ArcGIS Pro. That's one start to it. Now, every time you want to start to using a new technique, like let's say neural networks or support vector machines, or those are different techniques. Again, like the multiply sign, like the minus sign, the plus sign, and so on, like differential equations and so forth. It's just a technique. But to bring it in and do things to it, tell it like, look at this data, and I want to apply this to it by trying to classify data into X, Y, and Z. That's what you call an algorithm. That's what you will build for on top of it. Again, another thing to use data and to clean data, create matrices of data, do things to it, you can use R. R is another language, and if you search for R, CRAN, C-R-A-N, it's a statistical toolkit that is very easy. It's a bit like Excel, Microsoft Excel, but it's it's easier, more flexible to deal with it. You can start. There are million tutorials online for you to kind of learn how to work with R. So it's really, really easy to use.
Okay, let's jump to the second one. Which program? Which program are you working on right now?
Program as in software, or program?
I think
there's.
I think it's
Sorry.
meaning the program that you use in the presentation.
In the presentation, so it's mostly, I would say mostly the interface that we work on is usually notebook. So the Python notebooks. Python notebooks is, Python notebooks are, there's available Python notebooks that are open online. There's also ArcGIS Python notebooks that are small geospatial, so it has more GIS in it, more GIS functionalities in it, and you can even download that online for free. That's available online. Again, another thing, if you are more of a GIS user, but you want to implement a lot of that into your GIS, then again, it's ArcGIS Desktop that you definitely will use with which is when I say desktop, I mean ArcGIS Pro or even ArcMap if you still have ArcMap.
Okay, the next question. While using classification and ArcGIS program, there is an accuracy. Is there any accuracy in AI?
So accuracy in AI, there's obviously, so one of the things that you create is the basically a sort of an error matrix. So error matrices they're a bit like they kind of give you or confusion matrices. Basically, there's like confusion matrix is basically saying, let's say you classified something in a certain way, and then you got a correct classification of the right thing, so that's a true positive. But sometimes you get a wrong thing of the a true negative, like when you say like something is not what it is, it gives you so basically it's a test of a result that is correctly indicates the absence of that thing. Well, or the other side, which is a false positive, which is basically it tells you like it's what you said it is. So if you said that this is a house, this is not correct. But then if it says the false negative, so that it kind of goes, it's totally wrong. So they are wrong about the absence of certain things. So what I want to say is a confusion matrix is one of these things that kind of you can create in Python as well. In any one of those algorithms there, you can create your confusion matrix and it kind of gives you sort of an accuracy level of how well did your classification go. And that's again, based on how good, again, your data was prepared in the first place.
Okay, great.
I'll send the link for that as well on here in the chat.
Okay, the next one, the pre-trained models are for Esri subscribers only.
The pre-trained model, no, the pre-trained models are actually you can use that. You can download that normally. If you have ArcGIS Desktop, though, you can download that. That's for free. That's available for free for anyone. That's on our Live in Atlas.
Okay, are there different package data frames for spatial data science, or it's the same computer science?
So data science is more like saying when you say, let's say, digital technology, right? It's everything. It's everything. Databases, GIS, everything. But then when we say GIS, it's specifically GIS. So it's exactly the same. When we say data science, that's the generic term, like anything that is, data science, they develop algorithms around, and natural language processing is part of data science. GeoAI is part of data science, and so forth. But then when you look at GeoAI or GIS itself, you can start using machine learning with AI, which is GeoAI, basically, or what we call nowadays GeoAI, in order to start doing stuff that is geospatially aware. The difference is the type of data. So data, when you read in any data science, when you use Python, and if you're gonna start playing, if you're not developers and you start playing with Python, with R or Python, like I think Mary in the chat has mentioned, has put links to that. So thank you, Mary. Basically, if you start experimenting with that, you will realize the first things that the first data sets they provide for you, they're all like sort of tabular data. So they're all Excel, like let's say like Excel sheets type of things. They're CSVs basically that you start using, and so stuff that you kind of work on top of that. Now geospatial data or spatial data or GIS or whatever you call it, it's data that is a bit more complicated than that. It's not just X and Y, because it could be a point, which is X and Y, simple. But with a point, sometimes as well, you add a datum, so you add a geospatial reference, right? Like WGS84, for example, or whatever. Or you can also add to it time. You can also add to it, so it could be more sophisticated. But also, it could be not just that. It could be it could be a line, and a line is 2 points, or it could be a polygon, which is a combination, let's say, of 50 points, for instance. So when you have a polygon, it becomes the one polygon, which is one feature, becomes so complicated to store it and understand it and calculate. And imagine you have 1 million polygons, and you try and see intersection between 1 million polygons. The computation is very high, because it takes there's a lot of points that go into it. It's not just seeing, I have 100 points or 1 million points, and you try and see which is closest to which, for example. No, it's polygons. Every polygon has 50 points, for instance. So the calculations become difficult. The way you process data becomes different, and therefore, when you use Python packages, and when you go in Python, you start working with Python, there are different libraries that enable you to work with spatial data. ArcPy is one of them, which is the ArcGIS Python library. The ArcPy or ARCPY is sort of one of those libraries that kind of enables you to understand, enables the data science algorithm that you're trying to write to understand spatial data, but also do processing tools. There are so many processing tools that we've put in ArcPy that helps you deal with spatial data. It's not like, again, it's not like tabular data or CSV data that is just simple. It's just attributes or different columns. It's way more sophisticated than that.
Okay, next one. Can one work with maps instead of datasets using AI or other data science algorithms?
Sorry, can you say that again?
Okay. Can one work with maps instead of dataset using AI or other data science algorithms?
Well, I mean, it depends. So first of all, I will say not everything is sort of AI. So we shouldn't go around and say, well, I'm using, AI or machine learning to kind of do everything in my life, because it doesn't work that way. So some things are very similar, very simple. Sorry, that you just want to visualize some points. You put some points on a map in order for you to kind of understand. Just visualize the data, see where things are. And sometimes it's very simple as just visualizing things on a map, color coding things using choropleth maps, or just attaching a color code or color values or sizes or things of that kind of respect, or even having a 3D map of certain data with, let's say, certain attributes, just to understand the data. So it doesn't need to be, not everything needs to be done in or has to have AI in it. That's one thing. The second thing, if that's not enough, and let's say the amount of data becomes too much, that's hard for you to realize those patterns, the amount of attributes, not just the number of data rows that you have, but also the amount of data columns that you get, all the attributes you get. And if you're trying to find patterns between those different attributes, Now that's when you start using data mining. And apologies if I haven't mentioned the word data mining. So data mining is pretty much machine learning. It's the same thing, but data mining is more of, I have data and I want to mine it, and I want to go and search in it. I want to find patterns inside the data. Now, machine learning is taking the results of those mined data, those patterns that I've identified, and start using it for the machine to kind of say, well, if I understand already the patterns, now give me a new data set and I will start finding out what is happening, what could I identify, what I could classify, let's say, or how I can cluster the data in certain ways. So again, first of all, if it's spatial data, first of all, visualize it. That's the first thing any GIS person or any person would do. Just visualize it, see it in a map, see if it makes sense, see if you can see patterns already. And that sometimes, and lots of the time, that kind of helps you even to, if you're going to use machine learning, you're going to use data mining techniques, you're going to start already by an understanding. You already know that there is some sort of pattern in a certain way, and now I can start mining and verifying and quantifying how much that correlation is, how much that pattern exists.
Okay, next one. What are some of GIS research area that can use data science, especially in mining and environmental sector?
Okay. So this is this is quite a big broad topic. So there are certain things like, for example, in the environmental side of things, of understanding the growth, let's say, erosion, for instance, of shorelines. So sometimes you see the type. So there's a specific scenario that has been done with Noha in the US, where they have basically taken a lot of data sets of weather conditions, sea currents, so the currents within the sea, the movement of it, the shoreline, and the change of shoreline over years and decades of years, year after year. Other things as the type of soil, and which is basically it's sandy beaches or rocky beaches and so forth. But then they started finding correlations or trying to mine the data in order to see correlations of what factors do affect the erosion of the shoreline the most. So every year over the next year, or over the following year, you get an erosion of the shoreline, of the beach line. What is the most factors and the correlations that happen when they happen together? The shoreline gets eroded more and more year after year. And those are the questions where you have a lot of amount of data, and you just need to understand if there is a correlation and what does this correlation mean and how does it fit into the algorithm that you've got. So that's in the environmental sector. There are a few other things like again, you have an oil spill, you have a boat, a ship in the middle of the sea, right? And you have an oil spill. Now you can automatically nowadays lots of oil and gas companies have a lot of ways of algorithms that are already trained in order to understand where likely is that oil gonna move within the sea, depending on not just sea currents and other things, but it's also the likelihood of things based on a lot of environmental features. As a human, you cannot just tell where those things are, how things are, how that gonna fly. But it's just there's lots of parameters that becomes very difficult for a human brain to kind of compute that. And it's the same with, by the way, if you have a burning house, for example, burning places like when in Lebanon, for instance, you had that explosion that happened last year or a couple of years ago. There was a lot of there's a dust cloud, or say a plume that came out, and and they didn't know where this dust cloud is going to move after the explosion. Apart from the explosion itself, you need to understand where this dust cloud going to travel. It's going to cover certain areas, going to decrease the visibility in certain roads. So understanding the possibility or the probability of where this dust cloud is going to move is one of the questions as well you want to answer. And it has a lot of parameters, not just the wind and direction of wind. There's a lot of aspects to do with the type of material that's been burning, the terrain and the 3D model of the city and so forth. So there's lots of aspects that can go into, again, in environmental, generically into the environmental side of things.
Okay, how efficient is the data cleaning in data science? I would like to know how can train a machine to clean that to clean GIS data.
So cleaning GIS data, that's I think it's a bit of a broad question, but I think the question is more like focused on you have a lot of you have data and you want to verify this data. So if that data is of buildings, and let's say you have a layer of or feature class of buildings, let's say, right? And you have satellite imagery that's updated, and you want to see whether actually that data, that vector data that you have, that layer that you have, is correct or to a certain degree or not. Now, the idea here is that you can obviously overlay that, but you can start extracting from the satellite imagery using deep learning. You can start extracting the buildings in there, but then you take the result of that and compare it to the building infrastructure that you have. So cleaning the data, understanding the data that you have, that you actually GIS data that you have. This could maybe answer this question, but also there's in terms of the data itself, I would say, like, usually when we develop machine learning algorithms, I would say 90% of the effort goes into data cleansing or data cleaning. Basically, you basically get data if this data is not labeled in the right way, if this data is not organized in the right way and indexed in the right way, you always not and never achieve a high result or high accuracy result. So 90% of the effort goes into data cleansing. And that's why in ArcGIS Desktop or ArcGIS Pro, we've created a few lately in the last couple of years, created a few functions that basically help you label data or help you verify whether this data or certain data, feature after feature after feature, whether those are correct. And if you can physically, it zooms to it in the map, does this overlap with a building or a tree or whatever it's meant to represent or not? So kind of we've done a lot of or created a lot of productivity tools that kind of help you clean the data and in a very efficient and fast way, because that takes most of the effort.
Okay, we have a question from Mary. You said that young people should use the trial versions of the software and work on projects. Is that how you built your skill sets?
Well, I would say there's a lot of there are trial versions. There's also ArcGIS Online. ArcGIS Online can developer accounts. ArcGIS Online, you can create that for free. So that's a free thing already. You can create an account on it as a developer. There are developers and normal accounts on ArcGIS Online. You can create that and use it. You already will have access to tools. You can go to the you basically and Python itself. I would say it's just the first thing is just start getting familiar with Python in general. Outside of ArcGIS, like forget about ArcGIS for a minute. Start looking at Python libraries. Look at Python and start learning the basics of Python. If you're already familiar with Python, now anything else, spatial data gets way more difficult. So I would say start first, learn Python very well, be very good at it. Use R. R is easier than Python to understand if you're not familiar very much with programming. If you're familiar already with Python and things of that sort, take that to the next level. Go into start. You can again inherit or start bringing in ArcPy, into your Python environment and start working with it. You can have a trial version of ArcGIS Pro if you have already an understanding of what you want to do. Subscriptions as well are becoming easier and easier and cheaper nowadays. So it's really easy to kind of use and pick it up. I would say first, again, it depends on where you are. Everyone is different. And for myself, I had a GIS background many years ago, but also I was a researcher and I kind of had to work a lot on other libraries, on Python and other languages as well, in order to kind of bring things together for myself. And that's why I had as well during years in teaching university as well. So it is a mix of things. It's not just one thing. There's a mix of things. I would say if you're not familiar with Python, learn Python first on its own without anything. Learn the basics of it. because that takes some time to get by as well.
Okay, another question. How do you manage to deal with governments on these critical environmental and urban projects that deeply impact their citizens?
So, well, you basically manage. You manage. There's a lot of those kind of questions. So government issues are problems that can happen in government are very open. So some governments, for instance, have a very big focus on, let's say, homelessness, like people that live on the streets, right? And if you're a government that kind of is very much focused on solving this problem, then you work backwards and you start thinking, okay, so I have people live on the street. I want to solve this problem. I want to help people find the right help in the right communities, in the right areas. How do I tackle that? How do I provide the right houses or the right subsidized housing, for example, for people that live on the street, for instance? And that's when you go back, okay, what data do I have? Before you go to what data do I have and go to the roots of it, it's like what type of analysis I want to do in order to understand that. And that's when you go back and you start realizing, well, that's the data that I need. Do I have it or not? And even if you don't have it, how do I collect this data? And today, for example, in ArcGIS, for example, you have many mobile tools where if you have a survey group, if you have, let's say, a few surveyors with a phone app, you can download one of the apps that we have is called ArcGIS, ArcGIS Survey 123. So Survey 123 helps you kind of go and you can create a survey and give it to hundreds of people and tell them, well, collect data of where you see homeless people, for example, in the streets, or rubbish, or whatever, graffiti, or whatever you want to say, or for example, roads that have pitfalls or have cracks in them. And this data kind of automatically goes from the server, goes automatically to your database, to your infrastructure, your ArcGIS enterprise, and automatically you can see data being collected. So don't collect data and then start thinking about what do I do with the data. Always with governments, we'll see what do they want to achieve. What's their top goals? Is it sustainability? Is it social reform? What is it exactly? Pollution or whatever. But then you start going back. So what do I need? What type of analysis do I want to do? And therefore, what type of data do I have? What do I need to have? And whether if I look for the data, if I don't have it, how do I collect it? So that's how we usually kind of think about these issues. And there is a tool actually that we call that is called ArcGIS Hub. ArcGIS Hub kind of is this thing that basically helps governments in general on a lot higher level put their bigger questions, bigger aims and visions and missions, and then it kind of brings it down to what do I need to do, and therefore what type of data sets do I need to collect from different government organizations, if it's Department of Transport, utilities, or whatever. So yeah, so this is how we do it.
Okay. Do you find that these governments are receptive to your insights on projects?
I would say 100%, very much. It's very, I mean, it's not receptive just to GIS. So GIS is very important for governments, and governments realize it by, I'll tell you, not even analytics, not even the fancy stuff that we're talking about. They as soon as they see a map, they realize this is very interesting. I didn't realize this or that, and they start just the visual side of things kind of brings things to attention. And then, but lots of people, again, lots of government organizations that are not familiar with, they don't come from our world, they don't come from the GIS world. The first thing to say that's very nice, but what's the value? I don't see any. It's not going to save any costs for me. It's not going to help my citizens, because it's nice to see maps, but what do I do with this? And this is the idea, that to make sure that their analytics stays something. The map is not just a nice map for things, it's a map that communicates something to those government officials in order to take those insights and do something with it.
Okay, last question from Mai. She said, I studied our language and really have a question why some people prefer to go for R2 visualizing data and their analysis. However, some capabilities are available with ArcGIS Pro without coding. What do you think the advantage that lead data scientists prefer to go for R instead of ready tools available with Esri tools?
Well, I think it's different. Like okay, I mean at the moment I work for Esri, but I mean I don't. I really see like there's a tool for everyone. Like everyone does things differently, and you could love working with R. You're more comfortable working with the R environment and having the interface, which is good. You can still inherit a lot of the ArcGIS stuff inside R, but again, when you have the tools inside ArcGIS. And you also don't need coding. I mean, lots of stuff you don't need coding for, but sometimes you there's a lot of details or you want to break down things, and you're a data scientist or you're a computer scientist that wants to do more and more and more coding. Sometimes you start working inside ArcGIS in the kind of in the coding window at the bottom of ArcGIS Pro, which is very good. But sometimes you want to take it to the next level. Sometimes you inherit all that and you go to Python notebooks, and Python notebooks or ArcGIS has a Python notebook as well that you download and you start working with, and it creates all these things online. And it's not just ArcGIS Pro; it inherits and takes all ArcGIS Pro stuff inside of it. So it depends on the interface that you're familiar with. Now, R sometimes are people that already use R for years and years. Sometimes they're just more comfortable with it. I'm just saying that it's not. I mean, I wouldn't say it wouldn't say, well, this is one thing is better than the other. They all kind of connect to each other in the end of the day. So inside of ArcGIS, you will connect to everything outside of ArcGIS. If you're familiar and think your focus is more on the GIS, then 100% is so easy to just focus on that, and you can bring the whole world into ArcGIS easily and into, again, Python notebooks. Python notebooks is perfect for this specific situation because you write a code, automatically see the map, automatically it does stuff on the map. It's not, you don't have to code and then click compile or process, and then things will process. It automatically does it as you go.
Okay, perfect. Thanks, Dr. Adel. Hope you got your answers. Okay, great. Is there any question? If not, now we can end our session. It will not the last one. We will continue our series after Eid holiday, and we will handle mini courses related to GIS. Hope you can join us. And thanks all for joining us, and appreciate your time, Dr. Adel. And hope to see you. Hope to see you again in other sessions.
Thank you.
You are welcome. Okay, another question from Mary. Do you think that more young people are going to pick up the skills necessary with ArcGIS and spatial analysis to meet the problems of the future?
Yeah, I mean, the thing is, just like you had like, let's say in the past, like you didn't have anyone that was familiar with GIS. Today, you have everyone is familiar with maps. Everyone uses a map. Everyone has maps on their phones. It's exactly the same with spatial. When the data science community or in the analysis community, lots of people today, the first thing they've learned is GIS. And when I was in university many years ago, I 25 years ago or so, I kind of I can remember computer science or data science being a big part of the GIS world. And while studying GIS and working on GIS, computer science wasn't yet there to kind of take this up to make it more advanced. But today, people come out studying university, people already are being introduced to those concepts. People are already kind of starting picking it up. So it's and also the good thing about it is not an expensive thing or a difficult thing to do like you had to do in the past. You don't have to get again, like in the past when you used to have discs or CDs in order to download things and get things installed and so forth. Things are easier, more agile. You have cloud services today that kind of do all the processing. You don't even have to have a powerful computer. You can have a cloud computer and process. So It's all very manageable, and that's what helps people kind of understand more about spatial analysis and work with problems of the future. So 100%, yes, I think this will, if anything, is going to increase more and more and more.
Okay, great. Thanks all. Thanks, Dr. Adel.
Thank you.
Okay, and
Thank you, Dr. Adel.
have a great
Thank you
night
for your
everyone. Okay, sorry.
Thank you, Dr.
for
Noha.
your
Thank you very
great
much.
presentation. Okay, and nice discussion. Thank you. Thank you all.
Thank you.
Have a great night all, and hope to see you again in our next sessions. Please follow us to know the time and what we will present in next feature. Bye bye.